Hi everyone, I am Madam Rosmaya. In this video, we are going to discuss on derivation of potential divider for resistors and capacitors in series. Consider the two resistors R1, R2 in a series circuit supplied by the EMF E, and then the voltage across R1 is given by the ratio of R1 to R1 plus R2 times the EMF. For voltage across R2 is R2 per R1 plus R2 times the EMF. For capacitors arranged in series, the voltage across C1 is given by the formula C2 per C1 plus C2 times EMF. Compare these two. So for capacitors in series, we use C2, but for the resistor, we use R1 instead. So V1, R1, and for capacitor in series, V1, but here is C2. So for voltage across C2, we are going to use C1 per C1 plus C2 times the EMF. So how we get this equation or this formula? So let's discuss further. So we discuss for resistors arranged in series first. So for the first formula, the resistors are arranged in series, therefore the current is constant. So from the equation V equals to IR, if V1 equals to IR1 and V2 equals to IR2 and EMF equals to IR EMF, R effective, and we rearrange this becomes I equals to EMF per R effective. So what is R effective? For resistor arranged in series, the R effective is R1 plus R2. So we substitute into the equation, we get I equals to EMF per R1 plus R2. Okay, now substitute this I into the equation here. V1 equals to IR1. So I is EMF per R1 plus R2. So we can exchange the position because this only involves multiplication, so we can exchange the position. And the equation here is proven. So for V1, we use R1 per R1 plus R2. So the ratio used for R up here is R1. Okay, next we prove for the second equation. So we use the same method, substituting I into the equation here. And then we exchange the position, R2 and EMF. And again, we have proven the equation for V2. So for V2, we use R2 per R1 plus R2 times EMF. Okay. Next, we are going to discuss why for voltage across C1, if the C capacitors arranged in series, why we use C2 here instead of C1. So we are going to prove this. The capacitors are arranged in series, therefore the current I is constant. This means the rate of change flow, the charge flow is constant. From Q equals to IT. So I constant, Q constant. So from the equation Q equals to CV, Q equals to C1, V1. Q is constant. So C and V are changing. So if CQ equals to C2, so times V2. And V1 is Q per C1 and V2 is Q per C2. And Q also equals to C effective times EMF. Okay, now we are going to find the C effective. If the capacitors arranged in series, so the C effective is 1 per C effective equals to 1 per C1 plus 1 per C2. So we have discussed this formula before. So we use this equation for the capacitance, effective capacitance, if the capacitors is arranged in series. Okay, so we make this equation become one single fraction. So become C2 plus C1 per C1 times C2. And therefore C effective equals to C1 times C2 divided by C1 plus C2. So we make this becomes a single fraction. Okay, now we can substitute into the equation above here, into the C effective. Okay, next we can substitute Q, this Q into here because Q is constant. Okay, factor out 1 per C1, so in bracket here is Q so we can substitute in Q into the equation. Okay, next this C1 can be cancelled out. Now the equation becomes V1 equals to C2 per C1 plus C2 times EMF. Okay, so the equation is proven. That's why for V1, we use C2 instead of C1. Okay, next we try for V2 with the same method. Okay, we substitute Q, 1 per C1. Okay, factor out here. So the Q, substitute this Q into here. And then we cancel out C2. We use this same Q, substitute into here because Q is constant. Remind again, the Q is constant. So C2 cancel out. So the equation becomes V1 equals to C1 per C1 plus C2 times the EMF. So for V2, it is proven that C1 equals to C1 plus C2. So here got correction here. This is supposed to be V2. V2. Okay, so now we have the equation proven. So next we do example. Let's say this question, R1 given 20 ohm, R2 10 ohm, and EMF is given 3 volts. So what is V1? So without calculating the current, we can straight away use ratio of resistance to get V1. So in this case, V1, so here must use R1. So 20 per 20 plus 10 times the EMF 3 volt. So you get 2 volts. So V2 is 1 volt because the EMF must not exceed 3 volts. So 2 plus 1 is 3. Okay, for capacitance, let's say C1 is 30 microfarad, C2 is 60 microfarad, and EMF is 3 volts. So using the equation here, without calculating the current, we can straight away find the voltage across C1. The voltage across C1, we use C2 here. C2 is 60 per 30 plus 60 times D volt. Okay, so the answer is 2 volts and V2 must be 1 volt because the total of EMF is 3 volts. So if here is 2, here is 1. So be careful with the equation used for the potential divider, for resistance and for capacitance. Okay, that's all for the video. Okay, thank you for watching.